Hello everyone, in this video we are going to discuss the Carnot's engine and Carnot's theorem, and we will calculate its efficiency. First of all, consider a cyclic process. As we see in PV diagram, we have a cyclic process. Both are two are isothermal process and two adiabatic process to form it cyclic as well as reversible process. Let's consider here the point A at which the pressure is, for example, P2 or P1, and its volume is V1 and its temperature is T1. It goes an isothermal process A to B. It is an isothermal process. We know that the isothermal process, a process in which temperature remains constant, and if the expansion take place, the expansion is cause cooling effect and compression cause heating effect. We can write this expansion. If expansion take place, it causes the cooling effect, and if compression take place, it causes heating effect. Consider from A to B, the system goes from state A to state B. It is an isothermal process, and isothermal expansion can write is isothermal expansion. Then temperature remains constant. If the temperature remains constant, as we here discuss that the expansion causes cooling and this expansion also causes cooling, but the temperature remains constant in only the one case if the heat flows from the surrounding to the system, and for example this heat QH flows out of the system, out from the system surrounding into the system. The QH heat will be absorbed by system to so that the temperature remains constant. Otherwise, temperature cannot remain constant because we take place in an expansion of the gas from A to B, so that temperature remains constant. Now consider B to C, and B to C is another expansion as the volume increases. As we move towards right side, the volume will increase. If volume increases, it causes the expansion, and but it is called the adiabatic expansion. In the adiabatic expansion, the adiabatic means the no heat can enter to the system or leave from the system. We thermally isolate this system or thermally insulate this system. The delta Q is equal to 0. If the no heat can enter or leave from the system, and due to the expansion, the temperature will decrease to the of this system. The temperature will decrease due to this expansion. Now consider C to D. We consider C to D is another isothermal process, but it is an isothermal compression. As the graph goes from this C to this D, and then C to D, it is a compression. It is called isothermal compression. And due to this isothermal compression, due to compression, the heating effect will be there. Due to the heating effect, the temperature will increase, but because this is an isothermal expansion, in isothermal temperature remains constant, and the temperature only remains constant if the heat flows out of the system from to, for example, the QL heat goes out of the system, then the temperature can remain constant. Otherwise, the temperature can increase due to this compression. Now D to A to form the cyclic and reversible process. D to A, it is a compression but adiabatic compression. The adiabatic compression, no heat can enter or leave from the system, and the temperature will due to compression, the temperature will increase to temperature T1 as started from A at temperature T1. In this diagram, we can conclude that here is a high temperature reservoir and here is low temperature reservoir. The heat is entered to the engine, the heat engine. The QH heat enters to the system and QL heat flows out of the system, and according to this, the work is done. And here the work is done in this example. The area of the loop is work done, which is positive work done, and the work is done by the system, which is the useful mechanical work we can get from the system in this cyclic process. And we can calculate its efficiency, and efficiency can be written as the efficiency can be written as output divided by input, as the output is the work done, the useful mechanical work done, which can be get from this cyclic process, and our input is QH, which is heat provided to the system. The work done because of cyclic process, according to the first law of thermodynamics, delta Q is equal to change in internal energy plus work done, and delta Q is the difference of the heat absorbed and expelled to the low temperature reservoir, which is QH minus QL, is equal to change in internal energy 0, because it is a whole is a cyclic process, plus work done, and we can get the work done is equal to QH minus QL. The efficiency is equal to output is Q work done, which is QH minus QL, and divided by the QH. It can be written as the efficiency is equal to 1 minus QL over QH. As the ratio of heat and ratio of temperature are equal, we can say that as QH divided by QL is equal to TH by TL. Then the efficiency can be written as the efficiency is equal to 1 minus TL divided by TH. According to this relation, we can find the conditions by which we can get the 100% efficiency of the engine. To get 100% efficiency from the engine, we consider the 100% efficiency. The TL should be TL goes to 0. If TL goes to 0, the first condition, the TL goes to 0, the low temperature reservoir, the temperature of low temperature reservoir, if goes to the 0 Kelvin, then the efficiency will be 100%. We know that the temperature of the 0 Kelvin is impossible, then we can get from this condition the 100% efficiency is also impossible. The second condition can be the temperature of high reservoir goes to infinite. If the temperature goes to infinite, then the efficiency is goes to the 100%. And we know that the temperature of a high temperature reservoir cannot goes to infinite, which is also impossible. And we can say that the 100% efficiency of any heat engine can be impossible. This 100% efficiency is also impossible. We only increase the efficiency. How we can increase the efficiency? We can increase the efficiency by two factors. If we TL, if we decrease the TL and increase the TH, the low temperature reservoir, the temperature of low temperature reservoir is lowered, and the temperature of the high temperature reservoir if higher, then the difference of TH minus TL, the difference will increase. As this difference increase, the efficiency will increase. And here we are able to discuss the Carnot's theorem, which tells us that the no heat engine can get the 100% efficiency, or the Carnot's theorem can also state that The statement of Carnot's theorem can be written as the two ideal engines, ideal reversible engines operating at same temperature difference will have same efficiency. If we have two reversible engines and operating at the same temperature difference, the T1 and T2 is same, then their efficiency will be the same. As the efficiency only depends upon the difference in temperature, the T L divided by TH, only the difference in temperature, and TL and TH, not the substance which is operating in the system. This is this statement is called Carnot's theorem. Thank you for watching.